Okay, so this time we're going to graph using symmetric points. For this lesson, we'll use symmetric points, and we're going to use those to find the vertex. Okay, so let's take a look here. Okay, oh, joke of the day. Yeah, homework helpline. I need to have you explain the quadratic equation in roughly the amount of time it takes to get a cup of coffee. Poor girl in the back, and dad's got to go for the homework helpline. Okay, symmetric points. Okay. So here I got symmetric points are 2 points on a parabola which have the same y value. So if you take a look at this point here, this is y is 5, and there's one point at x equals -2 and a second one at x equals 4, which both have the same y value. These are known as symmetric points. And here's another pair of symmetric points, and here's another pair of symmetric points. Okay, so here's what we're going to do to do these ones, okay? Here's the step. We're going to pick any y value. We're just going to pick this right here. We're going to pick the c at the end. Okay, we're going to pick the c at the end. Again, these are steps to graph y equals ax squared plus bx plus c in standard form. So first we're going to pick the c. We're going to make y equal to c so it'll cancel out. Then we're going to find two x values for y. We're actually going to common factor. So in number 2, we're going to common factor each time. Okay, number 3, find the axis of symmetry. We're going to get 2 answers in 2, and just like yesterday, or not yesterday, the last lesson, whenever you did it, we're going to average the 2 values. Then we're going to sub that value in to find the q. Then we're going to plot it, and we're going to use that step pattern, that a in the front right over here. We're going to use that a to graph it. Okay, let's just jump into it. It'll be 3 lessons. I'll do one for each. Okay, and again, I'll probably use GeoGebra to check my work. Very first one, sketch y equals x squared minus 2x plus 3. Now, this one, if you were to graph, is probably going to be off the graph and probably has no x-intercepts, or their decimal x-intercepts. So this method you can use all the time. Okay, so there are cases where there's no x-intercepts, and you'd have to use this method only. So first, we're going to make y equal to 3. We're always going to make it equal the last number. So we're going to make it equal to this last number. So we're going to make y equal to this number. So we're going to make y equal to 3. That means 3 equals x squared minus 2x plus 3. Okay. So now let's bring this 3 over to the other side. Okay, so it's like 3 minus 3 equals x squared minus 2x. Oh, 0 equals x squared minus 2x. Okay, let's keep going here. Now, at this point right now, we can common factor. We can take something out of that side. Okay, we can take an x out. So we can get x minus 2. Okay. One answer, x has to equal 0. Or x minus 2 has to equal 0, the bracket. So either this x has to equal 0 or this bracket equals 0. And then we get x equaling to 2. Okay, let's see how this would look like on the graph. So we got x equal to 0 or x equals 2 when y equals 3. So let's take a look here. Okay, and let's graph it. Okay, we'll use blue here. So when y equals 1, 2, 3, x can either equal 0, that's our y-intercept or the number at the end, or x can equal 2. So at that y equal 3, x can either equal 0 or x can equal 2. Okay, look, these are symmetric points. The axis of symmetry has to go halfway between. So we're going to find the average to find the axis of symmetry. We're going to go down here and find the average. Okay, so P equals 0 plus 2 over 2. That's like 2 over 2. 1. So our axis of symmetry is 1. So let's draw it here. Okay, I'm going to go draw a line right down at x equal to 1 right here. That's our axis of symmetry, which cuts it in half. So x equals 1. We'll put the little arrows on the end. Okay, now let's figure out the next part. Let's figure out our q. We're going to sub it into the equation. So we're going to sub into y equals x squared minus 2x plus 3. We're going to put the 1 in there. 1 squared minus 2 times 1 plus 3. Okay, that's 1 minus 2 plus 3. And you don't have to do all this work. You can just get the answer there. The answer is 2. So our vertex is 1, 2. We can graph that now. We'll go on to the graph. Okay, our vertex 1 up 2 right here. Oh, see, we couldn't use the other method because there's no x-intercepts. Now, A equals 1. So our step pattern is 1. How do I know that? Because there's nothing in front of the x squared. So A equals 1. So we're just going to use 1, 3, 5. 1, 3, 5. So over 1, up 1. Over 1, 1, 2, 3. Over 1, 1, 2, 3, 4, 5. Okay. Now, same thing on the other side. There's another symmetric point on this side. See, it's across from it, and across from that one's another symmetric point. And there's our parabola. Let's do my best curve through here. Curve it up over here. Okay, we'll bring it up through here. We're at our arrows, and there's our first graph. Y equals, let's label it. Okay, y equals x squared minus 2x plus 3. Okay, y equals x squared minus 2x plus 3. Let's see if we did it right. Let's go to our computer software. Okay, y equals x squared plus 2x, okay, minus 3. Make sure I type that in right. Oh, it doesn't look right. Let's make sure I typed it in right. Let's go back to my equation. It's minus 2x. Whoops. And plus 3. You got to be careful there when I type it in. So it's minus 2x. Whoops. Let's undo that. Oh, cancel. Oh, there we go. It's minus 2x plus 3. No, not divided by 3, but plus 3. There it is. Our vertex, 1, 2, our two symmetric points, and our graph. Okay, I'm going to do the next graph on the next one, so you can join me on the next video where I do y equals negative 2x squared plus 4x plus 4, or you can try it yourself before I do it.